Hi, welcome back.
Hi.
How you doing?
Hi, ma'am.
Hi. All right, here we go. We're going to start today our new chapter, Ratios and Proportions. We got to start off small though. What is a ratio? If you guys are in, I think it's English 1 that's studying it. If you are in English 1 or took English 1, you might have studied Romeo and Juliet, and there's a character in there named Horatio. And so my joke is what is a ratio? And he's not a character from that story. He's, because it sounds the same to my brain. Look, I'm on medicine. Okay, ratio in math. What do you think a ratio is? Pin drops on floor. It's a fraction. And then everyone goes, ugh.
Oh.
Fractions. Really, the best way to think about a ratio is as a comparison of two numbers, two values. And you compare these two values using division. So you don't use addition or subtraction or multiplication or multiplication. No, said that twice. You use division. Okay? And that's what makes it the fraction. Okay? Now if we have a ratio, as in the math ratio, where we have some value, which I don't know, so I'm going to name it B, to some other value, I don't know what it is, but I'm going to name it B. And this second value, B, is not 0. We can write it two different ways. Well, three different ways. We could write it this way, right? Number to number. Or we could write it first number, a colon, second number, and this is going to be read A to B. Or we could write it as a fraction, in which case it's going to look something like this. And at that point, this thing gets read A to B, or A over B, or A divided by B. Okay? Let's do an example. In 2007, the Boston Red Sox baseball team won 96 games out of the 162 games they've played. Write a ratio for the number of games won to the total number of games played. Now, if we look up here on how we write this ratio, here's the word 2. In these forms, here's 2, and here's the 2. Okay? So in here, we want, there's the word 2. We want number of games, 1, 2, total games played. All right, so how many games did they win?
96.
196 games. How many games total?
162.
And so I can write this as 96 to 162. And if you gave me this, I'd be like, okay, boss, that's a great ratio. Or you could write it this way. And I would be fantastic, beautiful ratio. Or you could write it this way. And I would be like, a fantastic. It's a beautiful ratio. You don't have to write them all three ways if you don't want to. You can just pick your favorite. Okay, we're just making sure you can find the setup in a word problem. Okay? Because once you can find the setup in the word problem, we can do some more interesting things. Now, when you have three or more ratios stuck together. They're extended. And we can do things like using them to find the measure of angles in shapes. Notice that our ratio is now related to angle measures. And we're putting this variable in there to kind of show that the measures aren't really 2 degrees, 3 degrees, 4 degrees. Because that doesn't work for a triangle, right? Because if we add up all the measures of a triangle, we should get good morning. We just finished studying this. What? One what?
Good morning.
Good morning. If we add up all the measures inside of a triangle, what number should we get? 180. You're testing me with the 360. And so if I said that this measure was 2 and this was 3 and this was 4, 2 plus 3 is 5. 5 plus 4 is 9. 9 is not 180. These are the ratios of how the sides are related. This is 2 times some number, and that same number times 3 gives me this one, and whatever that number is times 4 gives me this other one. It's a way to relate how big the angles are in comparison to each other. Okay? So if I need to find the measures of the angles, I just add them up and set them equal to 180 and start solving.
Yes.
Okay, let's do that. All right, here I go. I'm writing them all down, adding them up. I'm writing that I have to add them up. I'm not actually adding them up yet. Okay, and now I'm going to go ahead and go through and add them all up. And now I need to solve for x. And x is 20? Okay. Am I done?
No.
Why not?
We have to find the ratio.
Because I got to find the measures of the angles. That's what I was asked to find. I use this ratio in order to help me find an equation that then I could solve that would let me figure out the measures of the angles. Okay, so the measure of angle J was given to me as 2 times x. But x has the value of 20. And so the measure of angle J is
40.
measure of angle K was given to me as 3x, but x has a value of 20. And so the measure of angle K is? The measure of angle H was given to me as 4 times x, but the value of x is? And so the measure of angle H, is?
80.
And if I add these 3 up, do I get 180? But they're in some sort of relationship.
They go by 20.
Yeah, they go by 20s. And that's what that x is like it's your counter, right? Feeling better about that? A little bit? Okay, good. Let's turn the page. We'll keep getting better at it. There's going to be another one that's going to look a lot like that. All right, I don't want to do all of these because I want to save some room for tomorrow in case you guys want to see another example tomorrow. I've got room to work, but I would like to do maybe 2 of these right now so that we can get a bit more practice before we move on to the next bit. Which one would you like to see as you kind of read through these? Which one makes the most disturbing? Number 4? Are there any others besides number 4 that you read and you go, yeah, nope?
5.
And number 5? Any others? 4 and 5. Okay. Let's start with number 4. The ratios of the side of a triangle is 8 to 15 to 17. So that's an extended ratio. We're relating 3 different pieces. The perimeter is 480. Find the length of each side of the triangle. This is really similar to what we just did with the angles, but this time we're doing it with sides. But I don't have a picture, so I'm going to draw one. I don't know what this triangle looks like, if it's obtuse or acute or right or I don't know. You know what? YOLO, it's a triangle. All right, and one side is going to be 8, one's 15, and one is 17. But these are in a ratio, which means that there's some sort of multiple factor, some sort of counter thing, like that 20 that we were counting by in the previous example. And we're going to use a variable to represent that I need to count by this much. Okay? Perimeter means adding up all the sides. So if you had forgotten that for whatever reason, we're going to add it right here. Perimeter means add all sides. And so I'm going to take this side, add it to this side, add it to this side, and say that is equal to 480. Hang on, it's going to look really dumb because I haven't switched colors yet. Okay. Uh, 40? 8 plus 15 plus 17? 40? Okay. Calculator's really good right now. Calculators are good. And x is 12? Okay. So I need to now plug 12 back into here. So 12 times 8 is 6, carry 96. Okay, I'll believe you. 15 times 12. 180, okay. Trying to do this in my head and it's not working. 17 times 12 is going to be bigger than 180. I wasn't wrong, guys. I can number. All right, you ready to look at number 5? The ratio of the measures of the 3 angles in a triangle are 7, 9, and 20. Find the measure of each angle. Oh, dude, this is the same sort of thing again. But unlike the first example, there's no picture. So I get to draw one. YOLO time. YOLO. One's going to be 7. The other is 9. The other is 20. And again, I've put that X in there as I've got to count by this much. What do you get when you add up all the measures inside of the angles of a triangle? They add up to? $180. And so 7x plus 9x plus 20x equals 180. And she says that that's 36. And so x is 5. Because someone has a calculator and is giving me those numbers really fast. I'm not even attempting to do this in my head. She's in front of me with a calculator and she's telling me numbers. Please double check her numbers. For the love of God. Check her numbers. I believe you that you're giving me the right numbers. We know me in numbers. Okay. We push those back in there, yeah? All right. 9 times 5 is? 9 times 7 is? And 9 times 9. 5 times 20 is? Easy peasy, lemon squeezy. We happy with this one? Mm-hmm. Does it feel really good to hit something in geometry that's like, I totally get this, guys? That it feels like stuff you've done before? Good. Good. I want you to feel comfortable with it. I want you to realize that the next section as we keep building is going to come back to just this, okay? We're just going to apply it to different shapes. That's all that's going to happen, okay? It's going to stay this easy. All right, let's talk about the proportions. When you have a statement that has two ratios and they are equal, we call it a proportion. Okay? So it's going to look like fraction equal fraction. Okay? In this proportion, B and D cannot be zeros because those are in the denominator. That means you're dividing by 0 and the universe ends. Please don't end my universe. The values B and D are the extreme values. And B and C are the mean ones. They're not very nice. Nobody invites them to the parties. Get it? So glad you went with me on that joke. All right, I'm just going to put some quick color coding in here. In case you too are following along with the Can We Color Our Notes game at home. Just trying to keep up here. Need one more color. Oh yeah, guys, taste that rainbow. All right, you've done this before, and this entire paragraph is setting you up for something you've already done. It's called cross product. Or, as you know, cross multiply. Anytime you've been staring at a fraction, then an equal sign, and then another fraction, you've been told to cross multiply. Okay? And it's because of this stuff. All right? So I'm going to color code these, and we're going to do some cross multiplication practice just to make sure you're okay with it. But we are going to call it by its proper name of the cross product. All right, so cross product says take the extremes, totally extreme, man, and multiply them together, and that is going to be equal to whatever I get when I take the mean ones and multiply them together. All right, calculator help. 432. And then I need 432 divided by 9.
48.
48? Did we do what we were asked to do? Yeah, we were asked to solve, which means get x by itself on one side of the equal sign. We have done that. We're done. Cross multiplication seem good? Yeah? Let's look at this thing in terms of a word problem. All right, we're going to look at it a political example. I'm sorry to bring politics into it. Couldn't be avoided. The mayor, Ms. Hernandez, conducted a random survey of 200 voters that live in her city. And she found that of those 200, 135 of them approve of the job she's doing. They like her. If there were 48,000 people, voters, in her city, she's asked us to predict the number who approve how well she's doing.
So that leaves the value of as x.
So we're going to use x for that one. That's right. So predict the total number of people who approve. We're going to use x for that. What we're going to do is we're going to set up a proportion because we have a ratio sitting right here with the total number of voters and the number of voters who approve. And so I can write that as 135 to 200. And if I set that ratio equal to the total number who approve of what she's doing in the entire city, divided by the number of people that are actually in the city eligible to vote, here are our total number of voters. Look, it's just a proportion. You see it? Cross multiply, solve. Is fraction equal fraction? Done. But the numbers are big and scary, and so I need help from the calculator gallery, please, because 48,000 it was. No. Scary. All right, help out. 135 times 48,000 is
648.
600.
Wait, no. 6,480,000.
That's a lot of people. It's okay, we're going to divide that by 200.
32,400.
32,400. And there is the number of people that if we went out and we talked to every single one of those 48,000 people who could vote, we would expect about 32,400 of them would say, yes, the mayor is doing an awesome job. Realistically, we can expect about half of them to go, who's the mayor again? Right? How many people know the mayor? I don't know who the mayor is. She's doing a lot better, though, than my brother. My brother ran for mayor of McAllen last year. My little brother, which is hilarious because I'm like, I remember you spitting up all over Dad's shirt, dude, and you're running for mayor. It's hilarious to me. Yeah. City of McAllen, about 150, 200,000 people. He got 230 votes. I wasn't one of them. I live in Harlingen. I can't vote in McAllen. They're two different cities. I would have voted for him if I lived in the city. All right, so we've got another page of examples. You guys tell me which ones that when you look at make you go, oh God, no. And we'll work on those, and then we're done.
3.
Number 3 makes you go, oh dear God, please, why? Any others?
5.
Number 5. Any others?
6.
Okay. 3 and 6 are really, really similar. If I did either one, would you be okay?
Yes.
All right, so which one would you really like to see done? 3 or 6?
3.
3. Okay. We'll save 6 for tomorrow if you still really need to see it again. Do you want to see another word problem? No. Okay, so then we'll focus on 3 and then on 5. So the cross multiplication thing that we've been working on doesn't say take part of the numerator. It says the entire numerator, right? So it's all of this as the numerator and all of this as the denominator and all of this as the numerator and all of this is the denominator. And so cross multiplication says take the extremes, the numerator of one of them, multiply it to the denominator of the other, and repeat for the other set. And now we've got some distribution stuff happening, which is only challenging if you don't keep track of what you're multiplying to what. Okay, so I'm going to use colors. Taste the rainbow, guys. I'm going to use colors to help us try to keep track of what we're doing.
The word.
Back page number 3. They're getting cray cray. Okay, so far so good? Alright, I'm gonna start solving this thing now. I'm gonna move the 10x because I'm a very big believer in positivity, and I don't like it when my variables get sad and start getting negative with themselves. And so if I subtracted 30, I would end up with a negative x, and I want x to be happy, so I want him positive. Get it? That was really weak, wasn't it? Yeah, I'm sorry. That really is honestly the reason why when I'm solving these equations I would do it that way. There really isn't another reason. Alright, what's the value of x?
8.
8. Okay. That's it.
Yeah.
Okay, if you look at 5 again, now that you've seen 3, does 5 make more sense, or do you want to see me do 5?
5 makes sense to me.
5 makes sense to me? I got a nod? I got a nod? You want number 4? Okay. We're just double checking number 5 before I move on. Number 5 is okay now? Yes, 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 yes. Nods? Okay. I had a call for number 4, so I'm going to whip through that one pretty quick. And then we'll be done because we've still got like 15 minutes left in the day, so there's plenty of time for us to get through this one more. Okay? As always, I'm going to set up my color coding so that you can keep track of where I'm putting what number and the reason for it. Trying to avoid saying the word Y because it's going to sound like I'm talking about that letter that's sitting there. Okay, so 3y equals 9 times 18.2. All right, gonna need help with that 18.2. 163.8. And then divide that by 3. Probably going to have another decimal.
54.6.
54.6. Okay. We all good?
Yeah.
Nice. That's all I had for you today. Thank you very much.